same story.
What was the theme?
It's really high and obnoxious.
I don't remember.
Was there an actual tune, or was it just like one?
Well, I can't sing it because
Chill. Stop.
You'll get EB.
the evening will vaporize me.
Okay, this is 9.21, conservation of momentum. Today we're going to learn about collisions and law of conservation of momentum. So this first slide here is actually really terrible, so I'm going to write the important information up here. But basically it says that if no outside force acts on the object, its momentum is going to remain the same. So if you have two objects with two different momentums and they interact, the momentum must add up because no outside forces are acting on that system. So that's basically conservation of momentum. It kind of comes from conservation of energy. It's very similar. But this, you can have in these collisions, you can have stuff where energy is conserved, energy is not conserved, but in a collision, momentum will always be conserved. So I'm going to talk about those different collisions right here. First one we have is elastic collisions. I know it says perfectly elastic. Ignore what's up on the PowerPoint. It's not right. So we have elastic collisions. In elastic collisions, we have energy is conserved, and the two objects bounce off of each other. Then we have inelastic collisions, and energy is not conserved. When I say energy is lost here, what I mean is energy is transferred out of the system. It's not destroyed. It's just no longer in the system. So energy is lost, but they still bounce. This is most collisions. Most of our collisions are actually energy is lost. But in your problems, when they start talking about collisions, a lot of them are treating it as elastic. And then we have the last type, which is perfectly inelastic. Energy is lost because it's inelastic, but they stick together.
What would be an example of perfectly inelastic?
The closest thing we can get at our level is like pool balls, billiard balls. But they are not really perfectly elastic because they make a sound when they hit, so a little bit of energy is transferred in sound. But they're pretty close. What would be perfectly elastic is things like molecule size stuff. Most of the time those would be conserved. And perfectly inelastic, this is like if you threw a piece of gum at the wall and it stuck. Yeah, so it's something that's going to stick to it. Or putty. They usually talk about gum or putty. Okay, any questions on that part? So, to talk about these collisions, again, we're going to talk about linear, so straight lines, head-on collisions, no glancing collisions or angles, not yet. We'll talk about that on Monday. Momentum in the beginning has to equal the momentum in the end. So you find the momentum of each object before the collision and set it equal to the momentum of each object after the collision. And momentum is made up of mv, so this is like the big equation. I'm actually going to teach you how to do a grid to do this equation here. And I think the grid makes it really easy because the hardest part is trying to figure out where the numbers go. So here's what that grid looks like. And you can do this with more than two objects. If you had 3 objects, you'd have 6 lines. If you had 4 objects, you have 8 lines. We'll talk about objects as A and B, but usually in here I put whatever the object is. So if it's a car and a truck, I'll do car for A and truck for B or something like that. So you're welcome to change that. But the first two are before the collision, the initial. And the second two are after the collision, the final. On the top, you're going to have MVP, mass times velocity equals momentum, or most valuable player, to help you remember. Just for your notes, I'm going to put the units in here. I don't usually write the units when I'm doing the grid. I just think that the first time I introduce this, putting the units in here kind of helps people. You do not have to write this every time. And momentum is just kilograms, meters per second. I know it's hard to see. This will work for any collision because all collisions, momentum is conserved. So depending on if energy is lost or not kind of decides if it's elastic or inelastic, but these are all collisions, so momentum is conserved. Again, we're talking about two objects that are free to move. So this is not an object that's interacting with a wall or the floor or something that is has external forces, like it's attached to the earth. So those things will not work. But anything that's free to move, when we're talking about collisions, we're talking about like cars crashing into each other, billiard balls. One of them is like a putty hitting like a wooden block. Those things are free to move. And usually we talk about them on frictionless surfaces, just to make it easier. Unless it says otherwise. So does this seem okay for now? Seem okay? Not overwhelmed yet? I'll show you how to use it in a second. Does anybody need more time with this slide? More time. Yeah, this class is 45 minutes, even though it's early release, because of lunch. You can't sell kidneys in school.
That's where he keeps his
His kidneys?
semen vials.
You know that's going to end up on the webs. All right, we're going to practice linear collision. So here's our first practice problem. So the 2 kilogram pool ball going 3 meters per second collides with a stationary 3 kilogram pool ball. The final velocity of the 2 kilogram pool ball is 1 meter per second. How fast is the 3 kilogram pool ball going after the collision? So there's a couple of things you got to ask yourself. We'll start with the first one. What's the mass of the first ball? 2. So I'm going to put it as A. The first ball will be 2. Notice that I put it up there twice. Every time I see A, that mass isn't going to change. What is the mass of the second ball? 3. So I'm going to put it up there again twice under both these. Next question. How fast is the 2 kilogram pool ball going before the collision? Say it again.
1 meter per second?
The 2 kilogram one? 3.
3.
So I'm going to put a 3 there. Then, how fast is the 3 kilogram pool ball going before the collision? 0. Why?
Is it stationary?
Stationary. Good. How fast is the 2 kilogram pool ball going after the collision? 1 meter per second. How fast is the 3 kilogram pool ball going after the collision? That's the question, right? We don't know. And since we're talking about velocity, I'm going to put a V there. That's the hardest part of all of this, by the way. You can fill out the grid correctly. The rest of it's easy. Okay. Anybody more time to catch up? A little bit more? Okay. All right, let's finish the grid here. What you're going to do is you're going to multiply mass times velocity to get momentum. So what is 2 times 3? 3 times 0? 2 times 1? 3 times v? 3v. All right, on the side here, you're going to add the first 2 and set them equal to the second 2. It's really hard to do algebra like this. So what we're going to do is we're going to rewrite the equation underneath. So it'll be 6 plus 0 equals 2 plus 3v. So solve from here.
Why couldn't we pick numbers that didn't suck?
Okay, this is okay.
That's it. We're going to do one more with the objects stick together, and that's pretty much it. Easy peasy.
I have a question.
Then we get to more.
So adhesion, like if an object is sticky, that's not considered an outside force? Because you're talking about putty.
It depends on what you're defining as your system. If your system is the object and the other object, and sticking to that object, that's an internal force because it's between the two objects, just like gravitational attraction between the two objects. If you're talking about just the piece of tape as your system, then you'll have a force crossing the line, sticking to the other one. So then you would draw that in the free body diagram. That would be an extra force.
Right. Is there any way for two objects to collide, both of them having an initial velocity of greater than 0, but both of them ending up with an initial velocity of 0? I mean, a final velocity of 0. The two
They
objects
started
are
with
moving.
0, and they ended with 0?
No, they started with velocity, but then they hit, and then neither of them moved.
If they are the same mass and the same velocity in the opposite directions, then the momentum initially would add up to 0, and then they would be in 0.
So they cancel each other.
Stop.
Okay? But
So
they have
would
to
they be-
stick.
But so they would be stuck together in effect.
If they didn't stick, then they would just transfer their momentum, because they'd be free to move away from each other. So if this had a momentum of 4 and this had a momentum of 4, they would transfer the momentum of 4 back. So they both end up with 4.
So would they go outward, or would they stick together?
If they were sticky, they'd stick together and stop. If they weren't sticky, then they would transfer the momentum.
So there's no way to have them stop moving unless they're sticky.
Unless they're sticky.
So if they stick together, wouldn't the final
I
velocity
feel like
be
that's
0?
cheating.
No, it's physics. Okay, so let's do part 2 here. Question 2. I want you to draw a new grid. Apparently it's
You need shirts.
Wouldn't it just be 0? But they stick together.
I don't need no shirts.
okay. So draw a new grid. MVP A B A B I F F. Okay, a 2 kilogram toy car going 3 meters per second collides with a 1 kilogram toy car going 1 meter per second in the opposite direction.
And the,
Then they stick together. What's their final velocity?
and the stick together.
And they stick together.
And
All right, so what's the mass of the first toy car? What's the mass of the second toy car? How fast is this 2 kilogram toy car going before the collision? How fast is the 1 kilogram toy car going before? -1. Opposite direction. One this way, one this way. Make sure they're opposite. How fast is the 2 kilogram car going after the collision?
Wait, what did I actually? It's
Unknown. How fast is the 1 kilogram car going in the opposite or in after the collision? Unknown. And they're the same unknown, right? Because they're stuck together. So since they're stuck together, they have to be going the same speed. Okay. Are we okay with that? If you can fill that out, you've got this.
So it's 91.
Opposite direction. Because remember, velocity and momentum are vectors, so they have to have either negative or positive on that. Okay, 2 times 3. 1 times negative 1. 2 times v. 1 times v. Rewrite.
So you'd just be 5.
Combine like terms.
Yes.
So about linear collisions, how can two objects hit each other in anything other than a straight line?
The glancing collisions.
And one. No different.
So like one here, and here.
Which
It's like when
way?
you don't hit a billiard tee.
Yeah.
It's going in the positive direction?
Yes, it is.
Okay, if they're both moving. But if one was
It is because this one has more mass and more velocity, so it wins.
So like they stick together and
So they're
then
gonna hit here.
They're just not going as
Still
fast
going
as this
straight
one originally was going.
So you don't know what the line is.
Balls here and you hit a ball here.
Okay, questions? You guys feel okay about this stuff? Like, let's do a practice. First clicker question is numerical. You're going to enter in the number. Remember, I like 3 sig figs.
since in practice.
This one says a toy car of mass 0.2 kilograms moves along a frictionless surface with a velocity of 0.18 meters per second. Collides with another toy car Y with a mass of 0.25 kilograms and a speed of 0.13 meters per second in the same direction. After the collision, toy car X continues to move in the same direction with a velocity of 0.177 meters per second. Calculate the speed of toy car Y. Now they're both in the same direction. One's just slower than the other, so you can use just positives here. And you don't have to label it A, B, A, B. You can label it X, Y, X, Y. They both have the same direction, so they're positive. Just one slower, faster.
Where are we going to problems for the back part or something like very top?
Yes, we are going to have that. But you can still use the same grid for it. Okay, this is a clicker question, so when you get the answer, make sure you put it in your clicker. So waiting on two people.